Let's look at graphing and finding domain and range for square root functions, and then graphing inequalities. All right, so we're going to start here with this one. F of x is the square root of x minus 2 minus 5. So we notice a couple of things. And in fact, let's graph this a couple of ways. The parent function of this is the function of x equals square root of x. And that one would be placed here. So 4 and 2 and 8, 9, 3. It would be a graph that would look like this, starting at 0, 0. This one has two changes. First, -2. That means it will move towards the +2. And then down 5, -5. Then we go 1, 2, 3, 4, 5. And then it would graph otherwise as normally because there's no stretch or other to it. So it would end up going like this one here. You can verify that with doing a simple XY table and taking the middle points, the opposite of that, and then the -5, that would be our starting point, 2 and -5. And we could put, so a 2 inside the square root would give us a 0. If we put a 3 inside the square root, 3 minus 2 is 1, square root of 1 is 1, we get a -4 there. 4 doesn't work good. Let's go to 6, because if x is 6, 6 minus 2 is 4. Square root of 4 is 2. 2 take away 5 is -3. So see, that's where I have this point, and this point, and this point to graph the equation. So there it's graphed. Now that it's graphed, we have to look and see the x's that are allowed for this graph. The ones that are part of it are these x's in green, starting at 2. So the domain is equal to all x's that are greater than or equal to the number 2. But the way we would show that, of course, in interval notation is to show it as from 2 and including it going to positive infinity. The range then, the color for that, I guess we'll use black for that one. Well, the range of the y values, so starting here at, what is this, -5 and going on up forever, so we're going, for the range, we're going that it's x's that are greater than, not x's, y's, because it's the range, y's that are greater than or equal to -5, and we'll show that in interval notation by showing -5 and then infinity. Oh, we're supposed to have the infinity sign there. So this is domain and range. And then, of course, the actual graph itself over here. Now notice we could have gotten and did get that 2 from here and the -5 from here. So the parent function, graphing that one, okay, let's come on down to it. And that one is actually like I showed for the parent function, the first one. I think I'll keep this one in red as well. Okay. So an XY table will confirm where it's supposed to go, because inside here, 0 is allowed, but we can't have less than 0. So whatever that is, that x that's in there has to be greater than or equal to 0. Just like above here, x was greater than or equal to, or no, it started with the -2. X minus 2 must be greater than or equal to 0. Add the 2 to both sides. That's where we get our +2. Now here, that means I put 0 as my starting point, and then the y is 0. If I make the x 1, the y is 1. Let's go to perfect squares. If I make the x 4, y is 2. If I go to 9, then that's 3. So that graphs us at 0, 0, 1, 1, 4, 2, and 9 would be about here, 9 and 3. Here, 4, 2, and a little bit outside of it. Well, what we have here are all the x's going that way and all the y's going that way. So for both the domain and the range, so for the domain, it's going from and including 0 going out to infinity. And for the range, it's going from 0 for the y's out to up to positive infinity. Okay, so that covers for the parent function. It makes sense going from 0, 0. And then this is the graph of the parent function. Now let's look at these translations here. And to graph this, so this shows if we put a -4 in here, we'd get a 0. Well, the way to think of this is that x plus 4 must be greater than or equal to 0. So subtract 4. X must be greater than or equal to -4. So I'll do a simple XY table, and I'll put -4 here. -4 makes that 0, so we get a -3. I can't do -5 because it would give me a -1 in there. But if I do -3, I'll get a +1. Square root of 1 is 1. 1 take away 3 is a -2. I'm going to go to 0 now, because if I put a 0 in for x, I get a square root of 4, which is 2. 2 take away 3 is -1. Now, I'm going to just temporarily put those points, well, not temporarily, but I'll put the points, but then talk about -4 and -3. -3 and -2, 0 and -1. Now the parent function is here, here, and 1, 2, 3, 4, and 2. That's the parent function. So one way to think about this should be that because of the +4, we're going to move to the left 4 spaces. So this point here, 1, 2, 3, 4. This point, the -3 goes down 1, 2, 3, and guess what? We're at the same place. And then it could continue from there. So that means that this, let's get it out there. That's a 4, 5, 6, 7, 8, 9 would be up 1. So we would finally get to there. And it's still going out there, starting from this point. So, oh, and then we need the domain and range. Well, the domain are going to be the x's that are greater than, that are -4 on to infinity. And the range then are going to be the y values. And the first y value that you get to coming up is at -3. So it includes -3 and then goes up to positive infinity. So that's the domain and range based on the XY table or on moving because of the transformations, moving over 4, moving down 3, we end up with this graph there. Now let's take a look at one that has a reflection, and this one has a little twist to it. Okay, so there are a couple of ways to think about it. Okay, and one of them is that we are going to take the graph and do, and of course the 0, 0 would be here, but we're going to deal with the reflection. Well, we have a couple of ways to look at it. And this one can be a tough one because one of the ways is confusing on it, makes it so it doesn't look, something doesn't make as much sense on it. So what we're going to do with it is we're going to go, we usually think of it as switching over the x axis, but it's actually really not. It's switching over the axis from where the central point is. What we're going to do here is we're going to go left -2, and then we're going to go up 4, left -2, and then we're going to go up 4. And if we graphed it from here, we would now have it be here, here, and you could put this into a graphing calculator and see that that's where it would be. But notice what there is now is this central line, and we end up flipping over that line. So we keep this point, this point comes down, this point comes down, and this point, the graph that would come there. So the actual graph is going this way. And in fact, I'm going to get a large, so we can see it. That's the way that's supposed to be here. And then I'll actually do green through it too. So this new line is actually the one that we reflect over. So we're going to reflect over that. And that's how we do this kind of a problem. Now we can verify that by doing an XY table. Okay. And I've discovered that the opposite for the 2 is so -2, and a +4 would be our first point. Okay, because if I put a -2 in here, it makes a 0. -0 is just 0, so we get a +4. Well, let's move 1 over to -1. That gives me a square root of 1. Okay, so it would be like this. So it'll be -1 plus 2 plus 4. So it's negative square root of +1 plus 4. Well, this is a +1, and that makes it a -1. 4 take away 1 is 3. And that, you see, is how I have this point. We're going to have to use that point, and then I have that point. Now, let's go out to another number here. It would be a perfect square. So a +2 would help me out here. Okay, so if I put +2, I'm going to work over here. -2 plus 2 plus 4. Negative square root of 4 plus 4. -2 plus 4. 4 take away 2 is 2. So then if I go to 2 and 2, I do indeed get this point here, which confirms that we're going this direction. That's the parent function, which is the square root of x. Then this one is going to be the negative square root of x plus 2 plus 4. Let's make that a little clearer at the beginning. This is the function of x equals, and then there's a negative in front of it then. All right. So this part here about the that it's not reflecting over the x-axis, but rather it reflects over the horizontal line that goes through the beginning point. Right, so that's important. Use this line to reflect. And the big thing, when in doubt, make an XY table. That's an important point there. That's really important. So now here, we have graphed that reflection. Now let's look at this problem that's a stretch or shrink. And in this case, it's a stretch because we're multiplying by a number that's greater than 1. So this is definitely better done with an XY table. Let's take that inside the dividend. No, so that's the quotient. This is the dividend here. And it has to be greater than or equal to 0. So we subtract 2, and x is greater than or equal to -2. And if I make the x -2, that'll make the inside here 0 times 2 is 0, plus 4, we get a 4. Now let's move, and I'll plot that, -2 and 4. Next, now I'm going to go to -1, one less, because, one greater, because here it'll make 2 square root of -1 plus 2 plus 4. This comes to 1. 2 times 1 is 2, plus 4, we get 6 here. Now, I want to put my x's numbers that'll give me a perfect square in the square root. Then I don't have to deal with decimals on any of this either. So my next one looks like it should be a 2, because it'll give me 2. 2 plus 2 plus 4, lots of 2's here. square root of 4 plus 2. So that's a 2 here. 2 times 2 is 4. Oops, okay, keep putting 2 there. That's 4. 2 times 2 is 4 plus 4. Now we get an 8. Those are enough to graph. -1 and 6. But notice that this is going up much faster than the other problems were. Or it starts off going definitely faster. It has a different kind of slope than the parent function or these others. Okay? And that's because of the 2 here. The 2 makes it go up much faster each time. It doubles each number when it wouldn't have doubled on the other problems. Okay, now domain and range. Oh, and I didn't do that on the other one, so let's do here first. The domain are all of these x's. So the domain are all the x's starting with -2 going up to infinity. And then the range, well, here is the starting point, and so on the y-axis, the range is there, starting at 4. So the range is going to be starting at 4 and going to infinity. So it's the y greater than equal to 4 is what I would put if I were not writing the integral notation. That's the range. That's the domain. It's this problem, this graph. And I'm going to come back up here and notice from the starting point here, going this way, our domain are going to be all the x's like before. So I'll write the domain for this one over here. The domain are going to be from -2 to infinity and including -2. But for the range now, we're going down. We have -4 is good. Oh, no, that's a +4. We have +4 is the starting point there, and it's a confirms. But then it goes down, -3. It goes from 4 to 3 to 2 to 1 and all the negative ones. So it's actually, the range is only including numbers from 4 down to -infinity. Instead of positive infinity, that would be only when they were going up. Okay, so that's the domain and range for those. Let's look at the bottom of this page. It shows now, let's compare the domain and the range for these. So I'm going to do it both ways, where I'll show that this is x greater than or equal to 0, which means it's from 0 to infinity. I think I'll actually put those in black. Black is from 0 to infinity, and including 0. So if I did this one, the domain, oh, well, back to the other one. For the range, it's all the y's that are greater than the 0, so it would be the same exact. For the y's, it would be from 0 to infinity. Now, in the next one, we have to take this +4 and say that x's, well, have to be -4 would make it 0, so that means x's are greater than or equal to -4. And over here, that -3 gives us the y's greater than or equal to -3. And we can make those interval notation, which is what I'm insisting on in these. -3 to positive infinity for y's. Okay, now on the next one here, all right, this one with the negative in front, well, it ends up changing that going down. What it means is basically going down instead of going up. So the domain, this little +2, subtracting 2 is greater than or equal to -2. And for the y's, it's going to be 4, but because of that negative, it's going to be all the y's that are less than 4, not greater than. Greater than. And then the last one, we still have the 2 and the 4, and that's actually not going to affect so much from the -2, so x's have to be greater than or equal to -2. And then the 4, we're going to include greater than the 4 because this is a positive number. Now, can we write this neatly? Greater than number 2. And here it's y's that are greater than or equal to. Oh, it's not greater than. Yep. 10 is greater than because 4 is that starting point. So we're going to go up from 4. Not down this time, but up from 4. Now let's turn these into interval notation. So these two will be the same here. And over here for the y's, it's the numbers starting at 4 and including it. Now, wait a minute. We're going down from the 4s, so I have to be careful here. And so it doesn't come first, it's where it's going to be from. If it's going down towards it, means it's coming up from negative infinity and going up to 4. Okay? And it includes it. So I should make that for any infinities, it's always a parentheses. So that means it's all the numbers that are less than 4, not, and I believe that's equal to over here. Yep. Okay, on the bottom one, it's all the ones that are greater than 4. So that means it's starting at 4 and it's going to infinity. This one gets an equal to as well. Then 4 and going out to infinity.